Check this out. Anyway, what we got here? There it is. Cleaned out the cell. Sorry. Cleaned out. There we go. Got it all nice and clean. That's real easy to see through. Got a metal plate in here. Piece of threshold. Out of the way, just hanging out. Reading differential on this load to ground. Alright, time for the earplugs. Hit the mute button. Get the scope in here, same shot. Water's clouding up pretty good. Okay, show it off now. Pretty cool, huh? Benefit to the reflections that are going on in between these two toroids. Sometimes I flip this, but it's effectively, I'm dealing with phase inversion every time I turn around through this entire circuit. So the signal comes in, it's upside down in the amp, in the preamp, and then it comes back 180 in the output, and then it comes to the toroid, it goes 180 again, and then gets flipped back 180 again, so it should match originally what it started with, or at least what it begins with. And so orientation is a little different. It's more of a singular, larger plate center, effectively, hard to say, and the bucking choke. Interestingly, I'm putting a capacitor between those two guys, so the shared 240 windings here, the terminals there, they're being hooked together, and I saw a good bit of amplitude increase from that, and it allowed me to then flip this one around and go back in the same 44 side. This is my input here, this is output down through back in the 44 side to this one, and then output here, the center tap output. These are two center taps. The other output is in with those two diode and the bucking choke and the load. Cool, huh? Getting pretty good. I pulled that out earlier because the wire was tangled and shorting itself out. Right after I shut it off, Damn thing zapped me 3 times. 3 times I touched it again and it zapped me. Ouch. This is what was off. Oh, there it is. Getting better and better. This is the best investment you could ever make, learning how to operate, to create a tube, a signal audio amplifier, because a signal audio amplifier is just what you need to create your amplitude needed to drive the additional stages of the circuit. These ended up weird. I printed these from Fire Pinto's thing on Thingiverse, and they came out alright. My printer was a little warped, plus I used white, and but I wrapped them with 36, and it wrapped beautifully, all thanks to Max's winder. But I get the strangest readings from them, into the tens of henries and kilo ohms of DC resistance, and I don't get any continuity. There's another one I printed, the sliding thing in the center here. So anyway, I got my 30, I think it's 60,000 feet or something stupid like that, so I can screw it up totally a couple times and make maybe 5 of them or better if necessary. But these are doing a pretty good job of providing magnetic isolation from the driving circuit, as well as reactive components needed to harmonic vibrate in the circuit. It's a weird, different type of cell design where I moved. I think it's still going. Oh, it's still turned on. That's the other thing. So this controls my bias, and this actually lets me turn the conduction down from the tube. So I'm raising or lowering the negative DC offset of the control grid on the EL34s, and this, the more I turn it up, the more positive it makes it, which means the more into class A mode it goes, where it conducts more current, up to 25 milliamp or 25 watts each. I'm sorry, 50 milliamp or 25 watts each, and it's all the way down. In fact, the more I turn it up, the less output I get, the more the wave tapers and power wattage increases, whereas wattage goes actually down. It's running about 56 watts through the variac, and then through the 250 watt limiter.